Welcome back. Now we're going to go over Amazon FSx. This is going to be a brief overview and how is it relevant to AI. But before we get started, hit the like button, subscribe, and share this to anyone who's going to take the AWS Machine Learning Associate exam. So, what is FSx? FSx represents AWS's portfolio of fully managed, third-party, high-performance file systems designed to address specific computational workloads and use cases. Similar to how RDS provides managed database engines like MySQL and PostgreSQL, FSx delivers managed file system solutions including Lustre, Windows File Server, NetApp ONTAP, and OpenZFS. Each FSx variant targets distinct workload requirements while providing the scalability, security, and integration capabilities essential for modern cloud-based applications. For AI and machine learning applications, the FSx family serves as a critical infrastructure component that bridges the gap between raw storage and compute performance. These file systems provide the high throughput, low latency access patterns required for data intensive machine learning workloads, including training large neural networks, processing massive data sets, and supporting distributed computing scenarios across multiple instances and availability zones. The managed nature of FSx eliminates the operational overhead typically associated with developing and maintaining high performance file systems, allowing data scientists and machine learning engineers to focus on model development rather than infrastructure management. Each FSx service integrates natively with AWS compute services and provides the performance characteristics needed for different stages of the machine learning lifecycle. So FSx simplifies the system deployments by managing infrastructure, patching backups, and scaling on your behalf, right? So FSx has four primary file system types. We'll see here. Right here, okay? FSx for Lustre, for HPC, that's high performance compute and machine learning workloads. FSx for Windows File Server, this is for Windows native SMB shares. Then FSx for NetApp ONTAP, this is for NAS migration or multi-protocol. And then you have FSx for OpenZFS. This is a ZFS-based Linux workloads. So each of these file systems serves distinct purposes in different enterprises and AI machine learning scenarios. Below, we'll get started for each one. All right, so how do you choose this? All right, FSx for Lustre builds on the open source Lustre parallel distributed file system. It's known for its exceptional performance in high performance compute environments. The name Lustre derives from Linux and cluster, right? So it highlights the origin in distributed computing systems where multiple nodes require concurrent access to shared data sets with minimal latency overhead. So FSx for Lustre delivers sub-millisecond latencies, hundreds of gigabytes per second of throughput, and millions of IOPS, making it the optimal choice for compute-intensive machine learning workloads. The service provides a native integration with Amazon SageMaker, serving as a high-performance abstraction layer between S3 storage and training instances. This integration eliminates the need to download entire datasets to individual training instances, significantly reducing training startup times and improving overall efficiency. The file system operates within a single availability zone, but can be accessed by compute resources across multiple AZs through appropriate network configurations. So this design choice optimizes performance by minimizing network latency while still supporting distributed training scenarios where multiple instances need concurrent access to shared data sets. Okay. Let's see. All right, so let's go into deployment models. All right. Okay. Okay. So there's deployment models and use cases. One, there's scratch file systems. These provide temporary high-performance storage optimized for short-term processing workloads. These systems offer up to 6 times the performance of persistent systems, delivering about 200 megabytes per terabyte of throughput with no data replication for maximum performance. The lack of replication means data loss is possible if underlying hardware fails, making scratch systems ideal for workloads where data can easily be regenerated or where processing time is more critical than data durability. Scratch file systems excel in machine learning scenarios like distributed training of deep neural networks, where training data can be reloaded from S3 if necessary. Batch processing of large images or video datasets, where intermediate results can be discarded. And experimental model development, where rapid iteration is more important than data persistence. Then you have persistent file systems. So these are long-term storage with data replication within the same availability zone, ensuring data durability and automatic recovery from hardware failures. While offering slightly lower performance than scratch systems, persistent file systems provide the reliability needed for production workloads and sensitive data that cannot be easily regenerated. So persistent systems are ideal for scenarios involving production model training pipelines with valuable intermediate checkpoints and shared data research data sets that require collaborative access across teams and feature engineering pipelines that generates reusable process data sets worth preserving. Okay. You can see all of this. Okay, let's go for some data loading in S3. Okay, so FSx for Lustre provides seamless integration with Amazon S3 through two distinct data loading patterns that cater to different performance and cost requirements. The integration enables the file system to serve as an intelligent buffer cache between S3 storage and compute instances and optimizes data access patterns for machine learning workloads. So you have two. First one is one-time load pattern. This transfers the entire data set from S3 to Lustre at file system creation. It creates an immediate access to all data with maximum performance. This approach incurs higher initial data transfer costs, but delivers superior performance for workloads that require frequent access to the complete data set. The pattern is ideal for training large language models where the entire corpus must be readily accessible. Distributed training scenarios where multiple instances need concurrent access to data, and iterative algorithm development where data sets are accessed repeatedly. All right. The second one would be the lazy loading pattern. So this loads data from S3 only as it's accessed, and it minimizes the initial data transfer costs and storage requirements. While the first access to each piece of data incurs slightly higher latency, subsequent accesses benefit from Lustre's high performance caching. So this pattern works well for exploratory data where subsets of large data are typically accessed. All right. Model inference scenarios where only specific data portions are needed and cost-sensitive development environments where minimizing data transfer charges are important would also be other ways that this would be relevant. Okay, so FSx for Lustre offers multiple storage configurations to balance this out, right? The balance is performance with cost. So there's SSD storage, right? This is the lowest latency and the highest IOPS. It's ideal for random access patterns, and it's common in database-like workloads or real-time inference scenarios that require immediate data access or small file operations typical in code repos and configuration management. Then you have HDD, like hard disk, right? So this delivers high sequential throughput at lower costs, and it optimizes for workloads characterized by large sequential data access patterns. And this storage type excels in video processing pipelines, batch data processing jobs, large scale ETL, and the operations where like sequential read-write patterns are just dominant. So the choice between storage type really depends on what you need, and it can impact your performance and costs. So with SSD storage, it'll cost more, but provides superior random access performance. And an HDD storage offers a cost-effective solution with pretty high throughput for sequential access to appropriate workloads. All right, so we'll go on a brief review on. Okay, so this is the big boy. This is where everything will be at. Okay, and you can dig into all of this. I would recommend it. All right. Let me see. Okay, some storage. This is good. So we talked about the SSD, we talked about the HDD, the high cost versus low cost, the high throughput, lower IOPS, higher IOPS, right? We talked about scratch and persistent. I guess the next portion would be, yeah, machine learning workloads. All right. So there's three basic services that will work for machine learning services. I'll go over this briefly. Amazon SageMaker. This can mount FSx for Lustre as a low latency training data source, which we talked about earlier. Then you have S3, and then FSx can act as that buffer for cache or layering for S3 data. And it can work with EC2, ECS, or EKS. And this is a mount for distributed model training, right? So the architecture would minimize the time spent downloading data, or it would speed up training or feature engineering or data pre-processing, right? And let's go into the console real quick and see if we can get in. Or am I out? Yeah, give me a second. All right. Now you can see how low my bill is because I keep track of everything. All right. So what you want to do is go to FSx. You can type it into the toolbar here, or you can click on the 9 side and go to storage, click on FSx. All right. All right. First, you click File System, and you can choose whichever one you want. ONTAP, ZFS. Windows File Server or FSx for Lustre. Excuse me. We'll just do that one. Then you choose, you name it, FSx test. That's a good one. In increments of 1.2. So that, or 2.4, or 3.6. Oh, of 2.4, increments of 2.4. Oh, so 4 point, oops, 4.8. Okay, so it's a lot of storage, right? So do you want persistent? Do you want scratch? Do you want persistent SSD, persistent intelligent tiering? Let's do that. Let's do scratch, right? We'll go into this. Yeah, we'll go into this a little bit. All right. And then from here, you do the data compression, you select your VPC, select your security group, select your subnet. This is all the default, so don't worry. Then you do the data repository information, your logging. So like CloudWatch logs to make sure everything's working. Your backup. Do you want to do a daily, weekly, hourly? Then you want root access in a Linux fashion, and you add your tags as relevant. Click next. You confirm, your attribute, the value, and is it editable after the creation? Did you get everything you needed? And you click submit. All right, or create file system. All right, but we're not going to do that because this is going to cost. We're not moving anything, but it's going to cost. Then you need to worry about your cost considerations. So how much are you storing? How much are you provisioned? How much are you doing for throughput? The capacity of everything, the volume of everything moving through, and then your S3 integrations, because S3 transfer fees will apply when it's reading or writing. But this is a good overview, and we'll go into other FSx servers or FSx instances and get you a little more input. Anyways, before we go, remember to hit the like button, subscribe, and share this with anyone taking the Amazon Machine Learning Associate exam. Thank you, and have a good day.